Okay, so now I'm going to talk about the atom. We'll continue talking about the atom. So specifically, we're going to talk about kind of aspects of size and distance in regards to the particles that make up an atom. So if you recall, we've got three particles in an atom, three types of particles. They're subatomic particles, also given the call. We have protons, which have a positive charge, sometimes written P+. Neutrons, which have no charge, sometimes written N0. And then finally, electrons, which have a negative charge, written E-. So these first two, protons and neutrons, they are found in the nucleus. And they are much, much bigger than electrons. So, to kind of give you an idea for what the size of these different particles look like, and these somewhat hypothetical, but this is kind of to give you a rough idea. So first, protons. Again, protons and neutrons much larger. So for proton, that size, positive charge. Neutron, zero charge, is basically exactly the same size. Tiny bit, hair bit bigger, but for all intents and purposes, we say that they're the same size. And then finally, electrons. So you see how big the proton and the neutron are. An electron would be about the size of that dot that I just put there. So, and even at that scale might not quite be correct, but it gives you a rough idea of how much bigger these are compared to this electron. So if we look at a nucleus, when we talk about the nucleus and the protons and the neutrons together, what we're meaning is that you've got, so an example of helium, two protons, two neutrons, a couple of protons, couple of neutrons. And so then, like, by convention, we just kind of say that they make up the nucleus of the atom. Those big particles lumped together. But now, for distance, that's a little bit different. So we're going to go back to helium, or continue working with helium. And so our scale here is going to be a little bit different. And so that dot right there is the nucleus. So remember that really, if you zoom in on that, it's going to kind of look like that. So if this is the nucleus, and we've zoomed out that far, and again, the scale might not be exactly right, but it's the idea to give you a kind of a representation of what it looks like. That's where the electrons are zipping around. Helium has two electrons to go with its two protons. And it would be a little bit more symmetrical, circular around that, but just a rough idea. So one thing that you notice, though, is that seems to be a lot of empty space between where the electrons are zipping around and the nucleus. And so when we talk about an atom and we mention like the atomic radius, which is a different distance from the outermost electrons to that nucleus, there's actually a lot of space in there. So a lot of empty space between the electrons and the neutrons. Sorry, electrons and the nucleus, so the neutrons and the protons. So with size, protons and neutrons really big, electrons tiny. And then distance, electrons way, way, way out far away compared from where the actual nucleus is.